see we don't have any lines for yellow. That means we're not really generating any steam. We actually don't want steam. This is basically a bigger version of what you guys have at home. Okay? So looking at the front, well actually let's walk it down by inputs. What do we need for this to run?
Water,
Fuel.
Water.
gas,
All right.
gas.
Where's our water coming from?
Oh, wait.
On the back
The
side.
pump on the back.
Okay.
Oh, this one.
So we have water coming from this line, going along here. What's this?
Expansion
Expansion
tank.
Expansion tank. Why do we need an expansion tank?
For the pressure.
For
The-
Not
the
pressure.
If there's
for
too
the
much
change
water
in the
in the
level of water in the loop.
Right. So if we're
Because it's a
starting with
closed
a cold hot
yeah.
water burner or hot water boiler, I'll just call it boiler. My water's going to heat up and it's going to swell.
Yeah.
We need somewhere for that water to go because it is a closed system. Okay. In this tank, when the boiler is cold, we got about a quarter of the tank full of water, 3/4 full of air.
Okay.
Is that a question?
Yeah,
That's an answer.
All right. So any overflow is going to come in here, but otherwise the water is going to come in here, past our butterfly valve.
Yeah.
What is this?
Strainer.
There's a
No
paper.
pressure.
Air
Separator, right?
Air
So if
separator.
there's any air in our system, that's bad. We want to make sure it's full of water.
Okay.
So we got a air relief on the top.
Okay.
Another butterfly come along here, and we've got what kind of a pump? And why is it running? Oh, that last class. I didn't shut her down properly.
Yeah.
All right, what type of pump is this?
It's a turbo.
Centrifugal. Excellent. What
Centrifugal,
kind of
yeah.
centrifugal?
Blue.
Volute. Okay. How many stages?
One single
One.
stage.
Single stage. Okay, and it's controlled by electricity. Okay, so we got our start-stop button here. We got our breaker box. Should always be in the on or closed position.
Yeah.
Okay, we follow this line. And we have to do a sharp turn. So we got a nice fancy valve here. And this valve allows the water to flow unimpeded
Okay.
from this direction to that direction. And then we follow the water line up.
Yeah.
Oh, it's this thing right here, this blue thing.
It's a differential pressure. It's a restricted orifice
Right, it's
It's
an
an
orifice
orifice,
plate,
yes.
right? So what do we use the orifice plates for?
for flow measurements.
We measure flow, excellent. So we got two air lines coming off.
Yeah.
It comes down here to this gauge, and that gives us our flow.
Okay.
Verifies that we have water moving, because unless we have water circulating, we're not going to be able to light this baby off.
Yeah.
Okay? So we go past the orifice plate, and we come down, and we got another isolation valve,
Yeah.
and then it goes into
Boiler.
the hot water boiler.
Yeah.
From there, where does it come out?
The other side.
The other side. All right, now if we lose water, how do we get more water in here? Where does it come from?
So the
Makeup.
Where's the makeup?
Couldn't find it.
Yep.
This is a small line.
Are you sure that's the makeup?
It should be near like a backflow preventer or something
Well,
like
let's
that.
look for it then. Where's the water coming from? This system here is actually used to filter
Yeah.
and put chemical in. So this is a chemical feed system here. So we're circulating the same water through with the chemical feed. Where are we getting extra water from? If we need it. Well, let's trace some lines. We know green is condensate. Not coming from downstairs to the aerator. Where is it coming from? That's where we're going to take. Find the storage spots that are condensate.
Which will
There's not much water coming through it, but could be, I guess.
yeah.
There is water, extra water going into it, right?
There's definitely, yeah,
So-
you'll be able to feed water in.
Could it be this little puppy here, but it's not much to it.
Which one?
This one.
Nope, that's not
Okay,
it.
all right.
That's actually being used for a
Sample?
sample.
Oh, okay. That's pure sample only. Alright. Unless it's a dual gas water pipe.
Yeah.
Says there's guaranteed more. I don't understand.
So this is our condensate storage. We use this water to feed the boilers. We also need makeup water. We're not going to put seawater in there because we want treated water, right? So, how does it get from this tank to that boiler?
No, the other one. Hose here. Nothing.
Is it this little line here? Uh-oh, you found her. You found it.
Yep, that's the one.
Dog. Yes, sir.
Good eyes.
Right on.
So we
said
can
let's
use
go. Killing it.
the little lines from this tank all the way over here. All right, so we've got water that circulates through the boiler, comes out the front. This valve is open. That valve's open. We can send it to this header here and distribute it over there. Or we can have it come back this way.
Okay.
Back through our system. So really it's a closed loop. We can open valves and direct it other places. So for example, I can have it come off this header here, come down through this pump here, and then I can send it off for cooling. But unless the pump's running, it's just going to be circulating front to back. All right, so we've got the water. What else do we need to have? Fuel. All right, where's our gas? Bright yellow. Okay, so we have fuel coming in. Awesome. Which one's in?
That's
That's
The big one.
the big
Right.
one.
Labels help. Vent.
yeah.
That's our exit if we need it. Okay, so the main gas is coming in,
Yeah.
and we hit a valve here. What kind of valve is this one?
Is the main shut off?
It's isolation valve. What
Yeah.
type of valve? Quarter turn.
Put up
Yeah.
on Volvo.
Ball valve? No. Black valve.
Black bulb.
Okay, it comes down here. It goes past this. What is this? Regulator. How does it work?
Pressure. It's a sprinkler that reduces pressure.
Yeah, it's going to reduce the pressure. Okay, so we step it down. Comes along here, and I got this. What is this?
Low pressure switch.
Low pressure cutoff switch. Okay, so this is being told to close this. Okay, this goes to the brain. The brain comes over here and says, quickly shut off. So these are very fast acting. So I've got low pressure on this side. And what's this one here? High pressure. Why do we have low pressure before high pressure?
That's the supply.
Are they
Pressure,
both
you're
bad?
going to be reaching as far. Low pressure wouldn't be reaching as far, whereas you'd be having too much pressure, you'd be going further down the system fast.
No. Not like that.
Oh, high pressure can vent out through here?
Or they're both designed to vent.
Oh, okay.
vent
Oh,
out
yeah,
there.
okay, yeah,
Yeah.
they do.
What do we need for combustion?
Fuel and air.
Oxygen, fuel, and heat or
Spark.
ignition. All right. So the airflow inside my boiler is based on the fuel flow, and they're equal. If I don't have enough fuel coming in, what's going to happen is it's not going to ignite, but I'm going to have a little bit of gas slowly building. And instead of hanging out at the burner, it's going to fill the whole furnace. So when we hit that lower flammable limit and it goes boom, right, there goes our boiler. So we want to make sure that we have at least enough fuel pressure for it to mix with the oxygen in our combustion gas for us to get proper combustion. So low before high. What's the special name for this system here? What's that referred
Double
to?
block of heat.
Right, double clock and bleed. So when we have a fuel safety cutoff switch go off, whether it's flame scanner, low combustion air, low fuel, whatever, both of these shut at the same time this opens. And this is now vented out to somewhere safe. Okay, so let's follow this along. What's this? Solenoid switch, right? So these are operated by electrical power, creates a magnetic force inside, and they're either designed to feel open or feel closed, depending on what your system needs. All right, we're gonna keep coming along here, and we come up to this thing. What is this thing here?
Yeah, the links the fuel.
Right. So when I increase my fuel, my air has to increase as well. If you're doing them separately, it's always air before fuel. Always, always. Okay? So this linkage here is set up to my blower fan. So when I increase my fuel, the louvers, not louvers, dampers in the fan will open up and I will get more air in. We're always going to have excess air, right? We don't want to have carbon monoxide. We're going to have extra oxygen to ensure we have carbon dioxide. All right, and that's going to go in to our burner. We also have this little line here.
For your pilot, right?
Goes to my vents.
To the vents.
This vent.
So that leads is from here. What's this?
Regulator.
Another regulator.
Yeah.
Okay. This regulator does not have a double block and bleed. So when this shuts off and this one opens, any fuel in this line is also going to go out the vent. Okay. So we've got this little guy back here. What's this guy?
Pilot.
The pilot.
Yeah.
So it's got its own valves.
Yes, isolation.
Right, so isolation valve, and if we follow it along, we've got another valve here. And when you're turning on your gas, trace your lines, make sure you've hit all of your valves in the right position. Okay, so we have fuel and water. What else do
One
we?
quick question: is that considered the main though, or is that the
This is me.
no the main pilot?
Oh, main pilot?
That one or that one?
This one.
That is the main. Okay.
Okay, what else do we need?
Spark.
Spark.
Yeah.
How do we have? Where's our spark coming from?
The air pressure switch.
Step up transformer.
Step up
Right, so we're
transformer.
looking around 5,000 volts, lots of power, good ignition. What else do we need?
Air.
Air. Where's the air going in?
First draft from.
Where?
Right in here.
Under here. So it feeds in under here. We got what type of fan in there?
First draft.
Forced forced draft, blowing the air
Forced draft.
into the furnace. The burner
The
has
bed.
got the fuel. It's mixing together in the right proportions. And when we have the transformer go off, it's going to go. We have ignition. What's controlling all of this? Our burner management system. So this is basically the brain. Okay, we've got a couple of ways we can operate this. Flame failure light. Anytime we have a fuel safety cutoff, we're going to have flame failure. Because when it's a safety cutoff, how it cuts off the equipment is it stops the fuel. Load demand. Are we actually burning or not? Burner switch on or off. Get our fuel flowing. Whenever we're starting equipment cold, we always start it up in manual and low. Okay? So close is low and manual. If I start it up cold and it's in auto, it's going to see that it's cold and it's going to race to warm up. Right? We don't want that because of that thermal shock happening. So we always make sure we're closed in manual. If I have more than 40 degrees Celsius on this, then I can consider it warm. I can automatically go to auto and open. We're just going to run it manual and close. That way everybody gets a chance to start stop and it's not going to stop on us automatically. Okay. This here tells us what our failure is. All right, and what condition we're in. So you're going to read here to see what it says. So how this is going to work. Hi.
Hello, Shelly. How are you guys? This is your second day here?
First day here.
First?
Yeah.
I mean, in the
Oh,
course.
week for this week? Yeah, we're like Thursday, so
Talk
fourth.
about.
Yeah. Are you on HVAC?
Doing everything here.
Oh,
I
you
mean,
are?
so,
Okay.
so what you doing here? Is that?
We just started here. Yeah.
Okay. So my guys, they run this, but I want to explain the heat sink. So if you run it for us, or
Okay. Cool. Yeah,
So you have to
we'll
boil.
give you some hot water. I think the valve on the taco,
yeah.
the flow control valve, is not working.
Oh,
So Susan was just using bypass.
okay.
So if you're gonna run it, I know Francis was up here looking at it, and I don't see him anymore.
For my guys, you don't have to run it. I just want to explain the control scheme they have there.
Sure.
So you have this today. Okay.
Okay.
We are here for 3 hours.
Are you here tomorrow?
No.
No. Okay. So we'll be up here tomorrow.
Someone else here, but not me. Okay, have a guy.
Thanks. Okay, so burner management system is going to control all of our safety cutoffs. It's going to make sure all our permissives are met. So this is an unattended boiler, which means we don't have to stay with it the entire time that it's running. It's going to run itself. So I have over here the controllers. One tells me what on-off looks like. So cold temperature and warm temperature. As long as we're between those two, it's going to fire. Or, yeah, it's going to fire. Okay. This is my high, or my main on-off. Okay, so when my boiler management system is running, this is going to control it on-off. This is going to sets my temperature. And then this one is my modulating. So modulating means when it shuts itself off because it's reached maximum temperature, it can drop to a certain amount before it kicks on again and starts burning again. Okay? When I have my burner management system does a fuel safety shutoff, part of what I have to do is I have to hit my resets. So these are my low water cutoff resets. I have a low water and I have a low water. Okay? Low water isn't going to cut off or stop my boiler. It's just a warning to let you know we need more water. As soon as you correct it, it's going to go back to working properly. If it drops below that, it goes to the low water. It's going to shut itself down. Okay? Because if we continue to burn water, obviously we're losing that water somewhere. There's not enough circulating, and we don't want the burner to overheat our equipment and cause damage. We got low. We have our reset here, resets here. Most of you aren't going to need the stool.
They need to be manually reset.
Manually reset when the boiler trips on the
On
low
low.
or low. Well, low. We're gonna trip on low. Okay, I've got a reset here for my burner management system. And every so often, it won't do the reset. We're gonna have to sneak in here. And push the reset there. Okay, if nothing else works. Your instrument guys would be having fits if they saw that. Okay, when the alarm goes off, it's going to be very loud. So if you're standing here, try to cover it with your hands. We are going to trip this boiler on multiple different places. So you're going to see how it trips and how to reset it and all the rest of it. Okay,
So if we're not supposed to be doing the reset, why is the reset on there?
well, there used to be a holder that you could reach in and... what is this? Flame scanner. All right, so that's going to verify that we have our flame. So what's going to be tell us we've got our pilot. Once we verify that there's a pilot, the main fuel solenoid will open, and you'll hear it click. It's pretty loud. Just because it tells you you've got a flame doesn't matter. You're going to come back here and you're going to take a look. We want to verify our flame, so it's the right size, shape, and color. Okay? You're going to get used to what it would normally look like. Here we don't have to cool the sight glass. It's just a pretty standard flame like what you have in your furnace. So we're not really concerned about the sight glass on this one. But when we move to the other burners, then we're going to have to make sure that it's kept cool and clean. All right, we're still talking about cutoffs. So we got the low cutoff. We have flame scanner cutoff. We have low water cutoff. We have low water cutoff. And we have air cutoff, combustion air.
Which is the fuel cutoff?
Fuel cutoffs are here.
All right. So
This
it's
is
two.
your high,
Yeah.
this is your low.
And even if someone wants to turn off the pump, it should come on.
It will shut down, yes. You don't turn the pump on, it won't even start. Yeah. So it also has a shut off on circulation. Flue gas, we do have a way of measuring our flue gases. It's here, I don't think it's actually hooked up. We can get away with it because we're not working in an institution, but when you guys are working at a plant, you need to know what's in your flue gas. You need to know oxygen, carbon monoxide, carbon dioxide. If you're burning fuel oil or coal, you're looking at sulfur as well. So all of that should have continuous emission monitoring system. And then every so often somebody gets to walk up to the exhaust and take a grab sample and do a test right away. Okay, have I got everything?
Does the low, so if the low only goes off on alarm and it doesn't shut anything off, right?
Yes,
So that will reset itself.
it will reset itself. Is that question number 3?
Yes.
So low water is not flow.
No, we have to keep flow. What is the concern if we lose flow? It's full of water.
May evaporate.
Great, we're going to generate pressure. So flow is very important, and that's why we have flow transmitters at the back, and we have flow transmitters at the front.
Yeah.
I think that's everything. Any other questions? Okay.
That's the one. That's the one we want.
This is our
Pressure switch.
it's our electrical switch.
Sorry, we'll let you off with that
It's
one.
what's it for? It just slipped my mind. It's measuring power, I believe. Okay, let's get this baby ready to go.
All
First
right.
thing I'm going to do is check my circulation, make sure my water is good. So I'm going to come out. That valve's open. Move around. Make sure all my valves are in the right position. That's open. That's open. That's open. I'm going to go on here. This is open. That's not good. What do I need to do with this? Why does it need to be closed?
Which one? For the pump, centrifugal pump.
Right, discharge, we always start with discharge closed, right? Okay, if we're shutting this thing down and it's still really hot, we're gonna shut down the pump last. Give more time for it to circulate.
Ellie, what about the valves that allow you to go everywhere else? They're all still open.
The valve set.
Go everywhere else.
So when it comes out,
Yep.
because it can go everywhere else, right?
Nope, because our pumps there aren't working.
Oh, so it won't even try to go
Nope, those lines are full, and unless we have the pumps moving the liquid in front of it,
Oh, okay.
it doesn't go
okay.
anywhere but in the circle.
Interesting. So it's gonna basically force it.
We're just doing a circle. Yep. So discharge is closed. I come up, around, butterfly is open. All right, water's good. What's the next thing I'm gonna do?
Check your fuel.
Gas.
Yeah, gas.
All right. So I'm gonna open my gas. My main gas is open. I'm gonna open my pilot at the same time. I'm gonna come along.
Is that a common trick?
Reset my trip. Come along. Reset my other trip.
And that's your test valve, right?
These ones?
Yeah.
It's just another isolation valve so that you can open her up. And come along here. One more there. Come along here. And that's open. All right, we got fuel. What else do we have to do?
Air.
Air. Okay, so we don't have to worry about combustion air because that's going to happen with the purge. Did I get my burner management system all set up?
Yeah.
I get 2 resets, right? I did my gas resets. What else do I need to reset? My low water and my operation. So somebody want to get those? Just push in the red button.
There's the best.
And then these 2 here. Awesome. So those are reset. Those are reset. That is reset. This here is just doing our continue. It's like a step. Yeah. Continuously monitors. Stack monitors. Okay. So now I've got water. I've got power. But it's not going to start unless I've got circulation. So I'm going to come back here.
Do you read like manuals and stuff?
I'm going to start my pump. I've got power here. I've got my pump here. I don't have any flow yet. I'm going to open my discharge. Okay, I have circulation. I have a measurement of flow, pressure at least. Got my power switch on here. Okay, my flame scanner is in there nice and tight. Let's give her a whirl. So it's going through its permissives. So permissives, it's going to do purge.
Purge, yeah.
So this is going to open. If you watch this leakage here, it's going to move the dampers to all the way open. It's going to purge for a set amount of time based on our furnace. And after the purge is done, it's going to check my fuel. You'll hear a click. That'll be the solenoid opening for my pilot. I'm going to go back and check to make sure the pilot's there. There's a 10-second check for it to verify there's a pilot. If it verifies there's a pilot, we'll hear another click and the main fuel line will be on. Again, I will go back and check to make sure my flame looks good. So right now we're high fire purge. We got 6 more seconds to go. I'm in my clothes and manual. That's where I need to be. What's my temperature on my water?
6.
Sorry?
36.
36. So it's considered cold. Okay, now it's moving to the low fire position, so it's restricting the amount of air that's going in so that we've got enough air for the pilot gas without too much extra. Here we go. So there's our solenoid for my pilot. Yep, I got flame. So my main burner now Set up my flame signal. I take a minute to verify that that's all in there, and then we're going to hear it start to hum. While I'm waiting, I'm going to walk around, make sure there's no noises. I got my valves in the right position, no signs of a leak. I've got flow, you can see that that's moving. Flame signal looks good. That's it. Shutting it down. Just the reverse. Last thing I did was turned it on, right? So I'm going to turn it off. I'm going to do my fuel. Okay, I'm going to close my discharge.
You shut the gas off?
I did. Yep. And then I'm going to stop the pump.
Did you flip the switch on the side of the water up here?
No.
No, that one. Okay.
You can if you want.
Yeah.
Generally, when you've got a breaker or a main power switch like that, you don't turn it off unless you're going to isolate.
Right. Okay.
Okay, so yeah, looks good. We're in standby. I'm still cold. I don't see any signs of any problems. Lock the book.
Nice.
Setting.